Hello everyone, in this video we are going to compare some oxidizing and reducing agents. So we have a couple of metal ions here and we are asked to rank each of these metal ions or their corresponding metals as either the strongest oxidizing agent or the weakest oxidizing agent, and then the strongest reducing agent for the metals. And then we ask a couple of questions, follow-up questions from there. So of course, the metal ions can be oxidizing agents because the metal ions can undergo reduction, right? So the metal ions can undergo reduction because they can accept electrons. The metals, right, so the metal form, once they have a zero charge, can undergo oxidation. So those, of course, can be reducing agents, right? So our first step is to rank them according to which is the weakest oxidizing agent, the strongest oxidizing agent for these ions that we are given the list of. So we're looking at tin, gold, zinc, cobalt, silver, and copper. And then we need to look at the strongest and weakest reducing agent of the list. All right, cool. So I went ahead and I looked at the list. So I just went to our standard reduction potential table and I got all of the half cell or the half potentials for each of these ions, and I put them down here in order of decreasing cell potential, half cell potential, right? So you can see we start with gold, it has the highest half cell potential, all the way down to zinc, which has the lowest, in other words, negative lowest half potential of the lot that we're given in this question. All right, and then of course we can remember what our trends are. So meaning the more positive the half cell potential is, gives it an increasing strength of oxidizing agent. So meaning its likelihood to be reduced. So in other words, gold has the greatest likelihood of being reduced of all of these species. So Au plus, meaning, sorry, the gold ion, the Au plus ion has the greatest likelihood of being reduced of all of these. In other words, making it the strongest oxidizing agent. All right, as well as the species with the lowest half cell potential or standard potential will be the strongest reducing agent. In other words, will be the species that wants to be oxidized the most, right? Because that's why it's the lowest on the table that writes everything as reduction potentials. All right, so it actually wants to undergo the opposite of how the table is written. So in other words, it is the strongest reducing agent because it actually wants to be oxidized. So that is why zinc here is the lowest. And that actually answers our first 4 questions, because which metal ion is the weakest oxidizing agent? In other words, what is the species that is the most, which metal ion is the weakest oxidizing agent? In other words, if we look at our trend here, increasing strength of oxidizing agents, in other words, which one is the most likely to be, or the least likely to be reduced? And that is zinc 2+. All right, so that is zinc 2+. So zinc 2+ doesn't really want to be reduced. It's happy to be zinc 2+. Au plus, on the other hand, readily wants to accept an electron, so it has a positive half cell potential. Zinc 2+ doesn't want to be reduced to zinc. It has a negative half cell potential. If you want to think about it like that, you can clearly see here now with them ranked like that. Zinc has the lowest E cells. In other words, zinc 2+ doesn't really want to be reduced. So that makes it the weakest oxidizing agent. On the other hand, then what's the strongest one? So the one that most readily wants to be reduced, that makes it the strongest oxidizing agent. And that means it is a U plus, right? It readily wants to be, I say readily, but I mean in terms of the rest of these, so it wants to be reduced the most. All right. Now, which metal is the strongest reducing agent? In other words, which metal wants to undergo oxidation the most? And for that, we must look what is our increasing strength of reducing agents. So in other words, the species that's the lowest on our little table here, and that is zinc solid. So in other words, it's the species that's most likely to be oxidized. So zinc solid or zinc is the species that is the most likely to be oxidized. It makes it the strongest reducing agent. It has the lowest or most negative E cell or half potential. All right. And the weakest reducing agent, well, it will be the species that would like to undergo oxidation the least. In other words, in this case, it is gold, right? Because it is quite a stable metal, and that actually, I mean, is commonly well known. So that's why gold doesn't oxidize readily, and why you can wear it around your neck and whatnot. All right, good. So that's the first few questions. Now we get to a couple of comparative questions where it says, will will tin, right, SN, solid, reduce copper 2 plus to copper solid? And the question is, we need to look at relatively where these two are. So this is where tin is, and tin lies below copper. So will tin solid be able to reduce copper 2 plus to copper solid? And the answer is, well, yes, because tin 2 plus would like to oxidize more than what copper solid would, because it has a more negative, it's a stronger reducing agent than what copper solid is. So in other words, if we're comparing those two, so in other words, it would then favor the fact that copper 2 plus would be able to be reduced. So in other words, you're basically just looking at, does it lie lower than the copper equation? And the answer is yes, because it is a stronger reducing agent. So short answer, yes, it is a stronger reducing agent than copper solid. All right, so meaning if you have tin and copper solid competing with each other, then the tin will cause the copper 2 plus to reduce to copper solid. All right, so and then the tin will oxidize to tin 2 plus. So meaning if you have those two competing mechanisms, whether or not the copper wants to oxidize or the tin wants to oxidize, then the copper is going to lose out in this, the copper is going to reduce, and the tin is going to oxidize, right? That's what you're comparing in this case. All right, next question is, will silver solid reduce cobalt 2 plus to cobalt solid? All right, so where is silver solid? Right, here's silver solid. And cobalt 2 plus is over here. And here we see no, right? So cobalt 2 plus is below the silver. So in other words, the opposite is actually going to happen, right? Because silver solid is a weaker reducing agent than cobalt solid. So in other words, cobalt solid is actually going to reduce silver solid. That's actually what's going to happen. So in this case, it's no. It is a weaker reducing agent. All right. The next question is, which metal ions on the list can be reduced by tin? Right, tin solid. So the question is, so tin solid is a reducing agent. Question is, which metals can be reduced, or metal ions can be reduced by tin? In other words, it's all the metal ions that are above the tin equation. So in other words, tin wants then to undergo oxidation, and hence the other species would need to be reduced that react with the tin. So it's anything that is above tin. Alright, so anything that lies above tin is a weaker reducing agent than tin, so hence tin will be the stronger reducing agent. So anything above tin would be able to be reduced by tin. So that means gold, silver, and copper 2+ can all be reduced by tin solid. Alright, they will all be reduced to their solid forms by tin solid, while tin is being oxidized to tin 2+. Alright, and which metals can be oxidized by silver plus? So silver plus can of course then oxidize anything that is below it, right? Because it is a stronger oxidizing agent than anything that is below it. So silver plus in the presence of copper solid, copper, tin, cobalt, or zinc, it will oxidize any of those metals, right? Because they lie below it and will be preferentially oxidized, while the silver undergoes reduction. Right, and that's how you use a little table like this, or how you use your bigger table. I mean, same principle applies. So if you have a stronger reducing agent or stronger oxidizing agent, it can reduce, or actually it can oxidize anything that is below it. Right, so for example, like the silver, this is a oxidizing agent. It can oxidize anything below it. So anything on the right hand side that's below it. If you have a reducing agent like silver solid, it can then reduce anything that is on the left hand side below it. Right, so that's the point. Not on the left hand side below it. It can then reduce anything that's on the left hand side above it. Sorry, oops. That's the point of this example. All right, good. I'll see you in the next example.